Good day, everyone. Welcome to Tutors. On today's episode on the differentiation series, we're going to do higher derivatives. Okay. The last video, in previous video, we're doing some techniques of differentiation. We'll cover the product rule, the quotient rule, the chains rule. Okay. So this next we're going to look at higher derivatives. Okay. So what are the higher order derivatives? What do they really mean? And how can we apply them in answering and solving our mathematical questions? Good. Remember that y is equals to a function of x. Good. And the y dx is known as what? You're going to differentiate this, the function of s once. Means differentiate once. When we have the square y over the x square, this one require derivatives. F prime prime x means what? Differentiate twice. Then we have the cube y over the s cube. That means f prime prime x means what? Differentiate the third time till the third time. Good. So it continues like that. They are called higher derivatives. Good. So let's go into questions straightforward. So given that, let's start this example first. So given that y is equals to 4s cubed, okay, find um y prime prime y prime prime prime. Okay, so find y prime prime y prime prime prime. What would that give us? So it means find the answer of differentiating twice, find the answer of differentiating three times. So these are function of x, right? So differentiate once, the y dx give us what? 3 times 4, that's 12x. 3 minus 1, that's 2, 12x squared. You differentiate again to get differentiate this answer. You differentiate the y dx once to get what? D square y over what? The s squared. That gives us what? 24x. And differentiate the square y over the s squared. The third time you get the cube y over what? The s cube. And that will give us what? 24. So this is our answer for y prime prime and y prime prime prime. Second, let's move into a more interesting question. 3 sine 2x. 3 sine 2x. Good. So find y prime, y prime prime, and y prime prime prime. So find the first derivative, the second derivative, and the third derivative. So y prime, which means differentiate once, means, so what would this give us? Okay, so this becomes, okay, let me give you a simple way that I differentiate a function, some trigonometric function. So sine of a function of x, and if you have something like this, if y is equal to sine of a function of x, the derivative the derivative becomes f prime x, hmm, which means differentiate what is in front of the sign, f prime x, multiplied by multiplied by cos f of x. Can you see that? Good. So that's the derivative of sine of any function of x. If you have cos of a function of x, you get what? F prime x multiplied by minus sine a function of what? X. Okay, for now, let us have these two, and I'll show you how to apply this in solving your derivative very fast. Go, we have 3 sine 2x here. So how can we differentiate this? This is just a constant, so it's just like 3. Okay, 3 is a coefficient, not like constant, coefficient. So it becomes what? Now take this, what did they say we should do? If you have something like this, what? Differentiate. F prime x means what? Differentiate once. Okay, differentiate what is here. This is f of x, 2x. Differentiate it once, what do you have? 2. If you add 2x, you get what? 2. So write 2 times what anything that you have here, you write it 3 Then you write this guy, cos. What is the function of x that you differentiated? The function of x, you know this 2x is your function, yes, you write it here. 2x. And that gives us what? 6 cos 2x. You can see how easy for it to differentiate. Now let's do y prime prime. Okay, you're going to differentiate y prime to get y prime prime. Now, eventually, of course, fx. Now, okay, let me try to improve this equation. So you have a sine this, I have put a here. So you can have the coefficients and you'll not be confused. Minus a. Okay, good. So a is like coefficients. I think this is a better improvement to it. Good. So y prime prime 6 cos 2x. Now you can see it looks like this, Sabi. So our differentiation will now become what? F prime x. Since here is function of x, f prime x will now become what? 2. Since f x is 2x, so f prime x becomes what? 2 times minus a. What's my a here? A is what is at the back of cos fx. Here is what? 6 minus 6 sine the function of x. What's the function of x that we have here? 2x. That'll give us what? Minus 12 sine 2x. That's our second order differential. So y prime 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 means you differentiate what? Y prime prime again. So this will give us what? Now we have this, the sign. Want to differentiate the sign? We'll go back to this. Our a here will what? Minus 12, have we? So let's go to our differentiation. Our function of x is 2x. So f prime x will become what? 2 times a. Can you see that? 2 times a. F prime x times a. Our a here is what? Minus 12. Cos the function of x. What's the function of x that we get? You've answered, right? That's 2x. So we have minus 24 cos 2x. And that's our final answer. Good. So for practice, I'll give you these questions for you to practice with. Work to do. Kindly comment the answers of this work to do in the comment section and tell me what video you'd like me to do next. A raised power sine x, okay, and b will be y is equals to 3x 4 minus 2x cubed minus 6x. Okay, good. So these two questions, find y prime prime and y prime prime prime. Thank you very much.